Hello guys, welcome back to my channel, Maison African Motifs. In this platform guys, we shall have a continuation, still working on the part that we have, which is a continuation from the question paper that we had from August 2021. Now we have the item, the part 2, which is on 2.3, where we are given the drawing in fig 3 below. Depicts how two rollers of 25 millimeters diameters are used for checking the accuracy of two inclined faces. Use the given dimensions to calculate the distance x. All right, so that's what we have, and as you can see, it's very similar to one of the questions that we worked on previously. So how are we going to attempt such type of a question? Since this distance is in the horizontal line, and we are also given a distance in the horizontal line, we are going to work with horizontal lines in this case. So take note here, it's just like the end of the circle where the circle is ending. So you are going to notice that there is a radius, because this is the center here, so there is a radius here, which is the same distance from this point to this point. That's a radius here. From this point up to this point is the same distance as the radius, which is you're going to obtain from the diameter, this one in millimeters. All right, which is the same concept also here. So you are supposed to redraw a sketch, guys, but I'm just gonna work with this one also here. This is a radius, a radius, a radius, a radius, so this distance is the same as the radius. All right, now what else do we have? We are going to see that there is a distance which is going to be obtained from this point to this point, this one, which is not a radius, because look at the circle is going to end somewhere here. So even this side, so there's a distance, this one, that is also involved. So let's just join this to this distance like this. So this is the distance that is going to be also included in this horizontal line. There is this small distance, this one. So let's just name our points. Let's just say this is A, this is B, then this is C. At this point you've got C there. Depend with what you want, but this is your radius, guys, and this you can just write it as O, which is the center, and this is O, which is your center here. All right, so we have got A, B, C, and I'm going to take my D. Okay, I can just put this as my D since I have taken awesome. Just put this as D here. So let's just say this is our D, and that will be our E and our F here. Okay, so or we can just put this and put our G here, which is this distance again. And this one you just name the way that you want, guys. It's not like you are putting some pressure of naming these, no. So there is another radius there, so that we can have something like this here. This distance is the one that we want to calculate, and this distance here. So let's take a closer look of what is going to happen here. This is a tangent, so which means here is going to be 90 degrees and here is going to be 90 degrees. So we have a right angled triangle, and this angle is going to divide the angle inside. Remember, angles on a straight line gives us 180. I'm going to talk about this later on. So which means the x that we are talking about is going to be taken from this, from A to G. All right, from A to G we are going to have something like this. It's AB, BC, which is the radius. So it's AB plus BC, which is the radius. Okay, the BC is the radius, plus CE, which is x. So it's plus x plus E to F, which is the radius, plus the radius, plus F to G, this one, which is the one that you want to calculate, plus FG. So this one we have it, this one we have it, and we want to calculate this one. So, and also A to G, we also have this one, it's 125. This one we have it, that's your 125 millimeters. So we have this, so we have to calculate this AB and FG. So these are the two things that you're going to calculate, since the radius is equivalent to the diameter over 2, and the diameter in this case is 25 millimeters. So it's 25 over 2, which is going to give us, that's 12.5 millimeters. So the radius is there, this one is there. So you're going to make X to be the subject from this point. Let's make X to be the subject, so which means you're going to transpose this to this side, and remember R plus R, that's 2R. So you're going to take this to the other side, so it's going to be 125 for AG minus R plus R, which gave us 2R. So if we transpose this, it's going to be minus 2R. Then oh, okay, we forgot this B, so this B to this side is going to be minus AB. This FG to this side is going to be minus FG. So let's calculate AB and FG. So we need to calculate AB, this one, this side AB. So where are we going to have the side AB? Okay, this is where we are going to take our AB from. Like I said, we are going to take this triangle here. This is the one where is our AB, this triangle here, like this one. So as I was saying, if you are to cross check, there's an angle here of 58, which lies on a straight line. So this is like this. If you are to cross check like this here, this is your 58, this one, that's our 58, and this is the part of the triangle that I want us to see, this one. So this angle and this angle, they are equal because this is a tangent here, this is a tangent, and this is also a tangent. So a line that is from the center like this of a circle is going to divide this angle into two equal parts. But we know that angles on a straight line, they add up to 180 degrees. So in order to find this whole angle, you're going to have 180 degrees minus 58 degrees. But we said these two angles, they are equal, so you then divide by 2 so that you can obtain one of the angles, so which is going to be 61 degrees. So this is going to be 61, and this is going to be 61, and this is a right angle triangle. And look at our focus. Our main aim is OAB, this triangle OAB. So let's just say use triangle OAB like this. All right, so this is your O, this is your A, this is your B. But we said from O to B, that's our radius. O to B is a radius, which is the same thing as this part here that we are having. We can use OB, which is the same thing as this one also that we are having here on this line. I shall talk about it later on, but that is actually a radius that we are having there. So that means I can replace my OB, which is 12.5 millimeters. Remember, that's my radius. So I want to calculate, remember, we want to calculate AB, which is this horizontal line, this one, AB. So according to this 60 degrees, this is your opposite, and this is your adjacent, this one. That's your adjacent, and that is our hypotenuse, this one. So which ratio uses adjacent and opposite at the same time? That's your tan. Remember from your soccer tour, that's what we have there. So opposite and the adjacent is for tan here. So that's tan 61 degrees is equal to opposite over adjacent. So our opposite is 12.5 over the adjacent, which is AB, this one, A to B that we want to calculate. So over 1, we are able to calculate AB at this moment, because we can cross multiply, and that is going to be AB tan 61 degrees is equal to 12,5, like this. So to find AB, we have to divide by tan 61 degrees by tan 61 degrees. So actually this is gonna cancel. That's our AB is going to be 12,5 divided by tan 61, which is going to give us something like 6,9. That's 9288631, something like that. So we can round off this to 3 decimal places. That's our AB is 6,929. This one is going to change at 1 because it's greater than 5, so this one is going to be 9. So it's 929, and the units were in millimeters, so this one is going to be also in millimeters. So that's our AB. Guys, don't forget why we are calculating AB. We need this on this formula here, and also we need FG. So let's put this AB aside. So our AB, we got 6,929 millimeters. So we do the same thing to calculate FG. So this time we have to calculate FG. This one is now there. So let's calculate FG. Calculate FG. So which triangle am I going to use this time? Let's go back to our diagram. Here's our diagram here. I'm going to use this triangle here. Remember it was what? D. We said this is D. So I'm going to use this triangle DFG. Yeah, that's DFG. Okay. So use triangle DFG, like this one. Alright, so it's going to be like this. Take note, there is something like this side, and we've got an angle here which was outside of 62 degrees. So this is 62 degrees. So like I was saying, guys, this part here is going to divide this angle into 2 equal parts, because this is a tangent, because there is a circle here. So you can say that this is a tangent and this is a tangent. So these two are going to be equal, but we know that this is 90 degrees and these two, they are equal. So, and also from this point D to this point F, because we said that's DFG. From D to F, that is from the center to the circle, that is a radius. So which means here we are going to use the radius. Remember our radius, we said is 12,5 millimeters from the diameter here. Remember these two, they have same diameter, two rulers of diameter 25 millimeters each. Okay, then this angle is on a straight line with these two angles which are equal. So we are going to use the same concept to find this angle. We are just going to subtract this angle from 180. That is, now we have got this whole angle, but these two, they are equal. So to find each of the angles, you divide by 2. So that is going to give us something like 59. So this is going to be 59 degrees. So that will be 59 here, 59 here. As we are going to focus with this 59 inside this triangle, because we want to calculate this side FG, which is on the horizontal line. So according to this 59, the angle of 59, this is your opposite and this is your adjacent. As you can see, we are given opposite and adjacent. So we can use still the same ratio of tan theta, which is opposite over adjacent. So that's tan theta, which is our opposite in this case, is this side DF, over the adjacent, which is FG. So we can have tan theta, which is this angle, 59 degrees, is equal to DF, which is this side DF of 12,5 over the adjacent side, which is the one that we want to calculate our FG. So we have formulated an equation that we can actually use to solve for FG, because we can actually cross multiply the two of them. So that's gonna give us FG times tan. That's FG tan 59 degrees, which is equal to 12,5, like this. So what am I going to do to remain with FG? Definitely I have to divide by tan 59 degrees by tan 59 degrees, like this. So that's gonna cancel. I'm now left with FG. So this FG is going to be 12,5 over tan 59, which will be 7,5107577, yeah, something like that. So you can round off our FG to 3 decimal place, which is going to be 1, 2, 3. So that's gonna 1, 2, 3. So that's 7,123. So this 7 can change this into 1. That's 511. So millimeters. So FG is now there. So now what am I going to do? Let's take this FG. We now have our FG here, which is 7,511 millimeters. So therefore, the question that I am being asked to calculate now can be calculated, because the question is asking us to use the given dimensions to calculate the distance x. And take note, guys, that's 5 marks for everything that we're doing here. So now you can actually apply the values to find x, because everything is there. 125, the one that we had, minus 2r. Remember, your radius is 12,5 millimeters. So it's going to be 2 times 12,5 millimeters minus AB, which is this one, our AB, 6,929, minus FG, which is this one, 7,511. So how you name the diagram depends with you. You can name in another way, but still you must obtain the same answers. Okay, so that is what you're going to have. You just combine everything together. You are going to obtain 85,56, just like that, which is in millimeters. So that's 85,56 millimeters. So that is our x at the end. So as you can see, guys, that's how they play around such typical questions, just for you to note or to understand this particular type of a question. So guys, you need to work with more questions and more question papers from past exam papers, so that you'll be able to actually understand how they ask these questions and how are you supposed to attempt, because it's a repetition. As you can see, it's a repetition of questions throughout. So the more you do these question papers, the more you are able to understand even what is to be asked in your final exams. So that's it, guys, from Mason African Motives, working on Mechanotechnics N4. Till we meet again.